Guys and girls, it's Noah time!
Alright, your lesson today, like I said, is on Pascal's Triangle. Pascal's Triangle really is just a little pattern recognition. You have to understand how the patterns work. Patterns. So, there's this guy. You can probably guess what his name was. Pascal. He came out, he was playing around with numbers one day. And I'm making this story up. Seriously, I don't know the story behind this, I make it up. So, he started with number 1. And if I drew, then you go add another one. So it looks like a little triangle. 1, 1, 1. Again, on the edges, I'm going to go 1, 1. And then what Pascal did was to say, hey, why don't I add the 2 ones from up here? And that's what he decided to put in the middle, which is 2. For his next line, he decided to do the exact same thing. 1 and 1. Okay. And he says, hey, look, why don't you get my next number here? Guess what he did? He added these 2 numbers. 2 plus 1. Whoa, 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 whoa. Which is 3. Probably, let me explain to you. 3. See, to get height. That's what I did. I went 2 plus 1. So then, there's another gap missing here. And he did the exact... Another 3. I want you to do the next 2 lines on your own, please. Start the next 2 lines on your own. And what he did, and this is known as Pascal's Triangle. So again, I'll give you a hint. 1 and 1. You guys miss a lot when you're in Cuba. It's like non-stop every day.
Oh, it's a holiday, man. It's a holiday from September. Shut up. No grumpy for 7 days, man.
So now, for which one? The first line?
The top one, yeah.
This one?
Yeah.
No, it's just a 1, 1 no matter what.
Oh,
okay. 4 is correct. 4, 6, and 4 is correct. See, to get 6, we added the top 2 numbers together. We added 3 and 3. Guys, you gotta do the next line, Yolan. Now, Pascal's Triangle keeps on going. 1, 5. And I'll let you just think about what are the next few numbers to go in there. Alright, Paul, what's the next one after 5? After 5. Oh, whoa, whoa, 10. Then it's going to be? 10. 5. See, now this is where things get a bit tricky. Every textbook uses a different analogy on what they'd refer. I like to call this my first row. Right here, that's row 1. Row 1. Sometimes the book calls row 0. Because they say, well, I'll just call it row 0 to begin with. Every textbook is different. I like to call it row 1 because that's where this is called row 2.
So you're supposed to draw it out?
Height. Height. Now, in terms of position, we know this is the first position, second position. If I ask you, what number is on the 5th row, 4th position? What number is it?
4.
Okay, so 5th row, 4th position. So we go, this is row 1, 2, 3, 4, and 5. So what number is it? 1, 2, 3, 4. Right there.
So that's
5th.
the one that's on the outside?
Height. So I would say my answer is 4. Because 5th row, 4th position is right here. Okay, very simple. What if I give you 6th row, 3rd position? And a lot of you went, I'm just going to count down, 3 to right, and that's really 10. And that's called Pascal's Triangle. Okay, position. The whole concept of Pascal's Triangle is I'm adding my previous 2 numbers together to get the next one. So this is equal to 10. On the exam, on provincial, I've seen this before. Actually, before I start, so what if I ask you? Hi.
Isn't there like an easier way to do it besides drawing it all out?
No, this is it. Hi. On the exam, they actually, I've seen this before. 17th row, 11th position. No, I don't have to draw it out. You have to. So, guys, gals, so now some of you say, Mr. Snow, I can't sit here for half an hour drawing out 17 rows. Takes too long. So is there a formula for it? The answer is yes. There's a formula. Okay. So the formula for Pascal's triangle. Because I don't want to sit here and write down 17 row. In 1 year, Ashal student did that. He forgot the formula, so guess what he did? He sat here for half an hour drawing 17 rows out, and so got it wrong. So he wasted half an hour, and I'm like, and he asked me for more, so I'm like, please. So the formula is actually this formula. This is called it.
Memorize the formula?
Hi.
You told us.
Whoa! It's very. You didn't even know the formula yet.
You said we did.
N
Yeah, he's got
C R.
Oh, that one.
Oh, is it that hard? Now, here's where some of you will make mistakes. Let's write this down. N plus 1 equals to row. Okay, this is the key. A lot of you will make mistakes because you don't know what N and R is. R plus 1 equals to position. I don't give you Pascal's formula on the exam because it's just NCR. If you can't remember that, well, you're in trouble, not me. So, N plus 1 equals to your row. What row I'm looking for? If I'm looking for the 17th row, 11th position, what does N equal to?
16.
18.
Oh no, not 18.
16.
16. Think about it.
You want 17th row.
I want 17th row.
We minus.
So, therefore, what must N be? N is equal to row minus 1.
Row minus 1.
I want you to tell me what R equals to.
N equals to the
It's 10.
R, this is why people make mistakes right here. Because they think N and R, they can't get these numbers. So N plus 1 is your row. R plus 1. So we just punch in our calculator now. 16, C, 10. Is it that hard? No, not really.
C again.
How do you sign hit math?
Can't you just give us the formula?
Oh, please. And do what? NCR equals to Pascal's triangle? You really need that?
N plus 1 equals row.
No, you can figure it on your own.
Wait, how do you punch it in?
I'm going to show you how.
Minus 1. Yeah,
Oh, please, Grumpy, please.
is it always going to be just
So you go 16.
beginning of the
Math. Go to PRB. And down to NCR right there. Hit 10.
What did you tell me? It's going to be so
So your number is 8008. Oh, guys, grow up.
What?
That was Sim.
Please.
That was Sim.
Here we go. Never mind. You don't want to hear it. Try this.
She's like, wait, what?
14th row.
You know the numbers you need.
See, 14th row, 8th position. Sean, what's your N value? Sorry? Whoa. 13.
That's what he said.
I thought you said 14.
I thought he said 14 too.
13. Kieran, what's R? 7.
That was all right. He's never baby that.
So here we go. 13. 17, 16. Guys, head it up. So my answer, 17, 16. So now the question is, why do we need Pascal's triangle? Because it's very basic and simple to know. You never need this in real life. Here's where you use it in real life. Why do we need... Nope. It's more fun than that, Pascal. Because really, what good is this going to do? It's why do we need Pascal? Here's the reason why. We're going to draw
I love these.
Some of you will love this stuff because it's your favorite thing.
So fun.
Is it actually?
Yeah, right, easiest thing ever.
So here's how it works. You've probably seen this in mind puzzle games. You're at A.
Mind puzzle?
Mind puzzle games. Mind. That's what I said.
You said mind puzzle.
That's what I said.
No, mind as in M-I-N-E.
Oh.
Mind.
Mind puzzle.
Why did I laugh?
I don't know. So the question is this: you're starting at A. You can only go right and down. How many ways are there going to be? Have fun.
Too bad you weren't saying something.
If
What is it?
So too bad you weren't saying something.
one way is it goes all the way straight and down, so it's one method. So it's one possible way. Or some of you say, Mr. No, I can just go all the way here, down, and to B. But if I consider all day, and it's just too many possible combinations, so there's a method using Pascal's triangle. Here's how Pascal's method works. I want you to draw Pascal's triangle on the side. Just see, I want you to draw 5 rows of Pascal's triangle just for practice right now. Each and every one of you need to draw your own Pascal's triangle. So yeah, let's practice. 1, 3, 3, 1. Just 5 rows. Okay. And I will show you where Pascal's triangle comes into play. If I look at Pascal's triangle,
1, 4, 10, 4.
oh, whoa, 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 oh, whoa, whoa.
Whoa, Mr. No.
Good thing you're paying attention. You passed my test. Good job, Ryan. You saw it. I.
It was the clean too.
I'm talking people to count. Come on, Grumpy.
Oh.
I'm kidding. Here we go. Think of Pascal's triangle. Think of it. Draw a line right through the one. Think of it like a very simple line. Okay. Draw a line all the way down. So this looks like a little triangle. Now, if I think of Pascal's triangle, think of this as A, the A point. Okay? Starting from A, on all the sides, notice there's little ones. So what we're going to do is I'm going to put a 1 here. I'm going to put a 1 here, because every corner on the side, there's a little 1. I want you to do another side too. 1. 1. See, it's just like Pascal's triangle, except this thing is tilted this way. So think of the relationship. 1, 1, 1. So if I'm going from A to B, look how I'm going to, what do you think this number is going to be?
2.
Height.
2.
2. Because look at how Pascal's triangle works. To get the next bottom number, I add the 2 top numbers together. So to get this corner right here, I'm going to add the 2 previous numbers. So this is going to be 2 for Pascal's triangle. Guys, I'm going to pause it. This is a 2. I want you to try this corner now. So to get this corner, guess what I'm adding 2 numbers together? I'm adding 1 and 2. So this is going to be 3. See? I'm just using Pascal's logic. I add the 2 previous numbers together. Find this corner right here. 4. So now I want you to go ahead and do the. Whoa. Okay, here's how.
3 + 1 is 4.
So you get this bottom corner, right? I add the 2 corners of my squares. 1 and 3, just like Pascal. See? To get the number 2, I add these 2 numbers. Height. So now I want you to get this number right here. 3. 6. And this is 10. And that's your answer. So there are 10 ways. That's it. Try this on your own. Okay, again, it takes practice. Start from A and always label diagonally. What if I were to make it a bit more challenging? Whoa. What if I were to say A is here, B is here? I'm going to turn it now. Again, always start with A. Label all the way to the left and all the way to the right, or top right away. So I'll give you a hint. Label these dots first. Doot, 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 doot. Okay, and just label upwards. They're all ones, just like Pascal's triangle. When you start with A, they're all ones right off the bat.
You're supposed to do the first one too, right? 8.
Height, that's a 1.
Oh, what if you want the other way though?
What other way?
Same thing?
Potato, potato.
That way? Like that way?
This way?
No, you know you started from 8, right?
Yep.
You made the 1, so you made it going up that way.
This way? This way?
That, yeah.
Yeah.
That, yeah, if you went this way.
Yeah.
That. Is that the same thing?
So this has to be always labeled as 1, 1,
Yeah.
1, 1.
And then if you went up right there.
Then there's going to be 1,
Instead of the other side.
1.
Does it matter what side you go?
It matters. It always starts on the corner A.
You never told us that.
Oh, please.
So Clean, if you're
15?
going from A to B, you don't
So
start
now,
at B.
see, notice.
So if you're going from A to B, you don't start at B.
If I'm going from A to B, I want you to do this, draw a little arrow like this right now, please.
You're up.
It says,
Are you talking about going right or going up?
Yeah.
so I'm going to find these corners right here.
Up that way.
So clean.
Take a minute, and I want you to find this corner right here. 2. Because this corner came from this rectangle right here.
So clean. In the end, you're labeling both sides
Okay.
anyways. You have to.
So this is going to
To
be
get that
2.
number then. There's no way to get the highlighted number. You're gonna have to.
So this is going to be 3,
Doesn't matter.
4, 5. Guys, gals, finish this for me. So now, I'm looking for these corners. See, this corner, yellow, came from this box, agree? Green box. So what 2 numbers are you adding together, Monica? Look at 1 and 2. Because you're adding, see, this corner came from the green box. So you're adding always 2 corners together. So this is 2 plus 1, and this is going to be 3. See? This corner comes from this box right here. Look at my hand. So I'm adding 3 and 3, which is 6. So guys, gals, we're almost there.
Wait, can you chill for a second?
Hi. 10. And finally, 15. I'm going to write a few notes down. Star. Always look at the smallest box of the corner. This sounds confusing, but I'll explain to you. At the smallest box
It's 15.
height of the corner. So that's how many ways there are. That's your first crucial hint when doing this. Crucial hint number 2. And this is where students make mistakes.
What do you mean the smallest one?
I'll explain to you when time comes. If you cannot add numbers together, then use the previous number. A lot of students will have no idea what I'm talking about until I give you a question. Previous number. Okay. If you cannot,
The arrows first, no?
oh, I'm just showing that to go from A to B, I'm going this way. So which means I'm adding, to get the top right corner of each one, I add the 2 corners together. I'll explain to you, don't worry. What if I give you this? Wow. Whew. A. B. Good luck. How many ways are there of going from A to B? Again, always start off with A. 1, 1, 1, 1, 1, 1, 1, 1. And then slowly figure things out. I'm going to pause it. I'm going to quickly do this. I start here as 1. Here's a corner. Here's a corner. 1, 1. Here's my next corner. 1. Guys, gals, so notice I'm going this way from A to B, which is, so all the bottom right corners are the ones that I need to add together. this is a bottom right corner. So you can figure out what that is right now. 2. To get this number, remember, I add here's my box. Watch my hand. So I add 1 and 1 together. So this is going to be 2. Some of you now are stuck and say, Mr. No, I can't do any more because I'm missing numbers. What do you think this blue one is going to be? 1. Because, let's read what it says. If you cannot add numbers together, use the previous number. See this blue one, I can't add anything because it's not part of a bottom right corner. So what I'm going to do, I'm going to use the previous number, which is 1. Put a 1. Because you're only adding bottom right corners.
What do you mean previous number?
So previous number to this one is a 1. Right there. So I want you to put a 1 right here. And then, some of you are saying, what about this one? That's a 1 also. Because this is not a bottom right corner. It has to be a bottom right corner before you add. If it's not a bottom right corner, you got to use the previous number. The previous number to here is 1. So we put a 1 right now. See, look at this one. See, look, this is the bottom right corner. If it's a bottom right corner, then we add. If it's not a bottom right corner, we use the previous one. That's why we need to know the direction you're going to. So this is going to be 3. Look at this one. Is this the bottom right corner or is this simply 1? This is a bottom right corner. Because here's where the box comes from. See? There's the box. So this one right here is a bottom right corner. So I add these two corners together. 1 and 1. Wait, what's going on? What's going on? 2. So guys and gals, so my answer is going to be 5. Whoa. Try this one. For what?
Whoa, let's go. What happened if you play with fire, you get burned?
I know. Grumpy played with fire the other day. She got burned.
What did she do?
I can't say.
What she do? Can you say it?
He does it.
What?
Has something to do with hot dinners.
He does it.
So guys, gals, A to B. Let's see how we can figure this one out. So I'm gonna go corner 1, 1, 1, 1, 1, 1, 1. I'm gonna label this now 2, 3, 4. See, every bottom right corner is one I add. 3, 6, 10. 4, 10, 20. I got up to here. And then somebody stuck. Somebody say, Mr. No, what are these corners right here? Or they are 20. Because these are not bottom right corners, so I'm going to use the one previous to that, which is 20. Put 20 here.
What do you mean?
Bottom right corner. So notice which way I'm going. I'm going from A to B, right? So every bottom right corner, like this one, are derived from adding. Okay? If it's not, let's say this number is not a bottom right corner, so I use a previous one to it. Okay? So now, this is going to be 20. See, this is a bottom right corner. Would you agree?
Yeah.
So if it's a bottom right corner, I add the two corners together, which is 40. Some of you got stuck here. What do you do now?
Use the 40.
40, 40, 40, because they're not bottom right corners. So I'm using the numbers previous to it.
So that would be 80.
It'd be 80.
And then 80.
120,
120.
120,
240.
240. And there's your answer, 240. This is called using Pascal's Triangle. Whoa. Here is, what question? Other side? Oh, well, what other side? Same concept. Here, actually, I'll give you one more question before Super No. Try this. Yep, I know what are you referring to. A, B. How many ways can you go from A to B? Notice which way I'm going now. So it'll be the not bottom left, top left. So every top left corner must be derived from adding. And I'll give you a hint because I'm a nice guy. 1, 1, 1, 1, 1. The rest is up to you. So I'm starting with every top left corner must be added. Top left, top left, top left. 2. Be careful about this one. What is this going to be? 3. This is going to be 4. So now I want to go to the next square. So I'm going to use a previous number. So 4, 4. Whoop, come on. 4, 4. So guys and gals, finish off the square now. The middle one. This is going to be 8, 12, 12, 24.
3 plus 1.
Okay. So now I'm going to keep on expanding. 24, 24, 24, 24.
48.
48.
72.
72.
96.
96. Was it that hard? No. Not really. Pretty fun stuff. Here is your super nose question for today. Good luck. Again, I want to make it, this is going to be individual challenge this time. You have to get it right. One shot, individual challenge. Simple as that. This is not a team challenge. Whoa, whoa, whoa. If you look at your neighbor's work, I will eliminate you from this competition. Good luck.
So what if you and your neighbor are both correct?
I'm still debating how I'm going to do this, how I'm going to modify the question. Again, full work must be shown. No work, no marks. Huh, interesting. Draw a box. Very, very simple. You have to show the work, just like what I've been doing. A to B. Wowzers. Good luck. One shot. I'll give you 3 minutes maximum. At 2:43 is my walk. Whoa, 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 whoa. Watch what I'm going to do. I labeled this as 1, 1, 1, 1, 1. I know that every bottom... The what part? Better make it quick. See... Goodness gracious, guys. See, every bottom right corner. Here's a bottom right, bottom right, bottom right, bottom right, bottom right. All these are my bottom right corner, which means I have to add to get those corners. So this is going to be 2, 3, 4. This is 3. But if I look at this one right here, I realize it's not a bottom right corner. It's a 2. So Robert, what's your answer? Okay, we'll see who's right and who's wrong. This is 2. Height. Oh, this one? Because I have to use the previous one. The previous one is here, not here. This is going forward. Okay? So now, I'm just adding all the previous numbers together. This is going to be 5, 8, 9. Now, this is 17. But... Oh, why is this 5? Because I have to use the smallest box, right? 2 and 3. I get up to here. So now, this is going to be 8 and 9. Because those are not bottom right corners. This is where students are having trouble with, bottom right corners. So I'm going to add these together. 17 and 8. 25 here. Okay. This is going to be 26. We're almost there, guys. Few more to go. This, would you agree, is not a bottom right corner, so I use the number previous to it, which is 17.
Why is that a bottom right corner?
Because this is not a bottom right corner. This is a bottom left corner.
Wow.
Because
It's on the left side.
left side. This is a bottom right corner. There's a difference between left and right.
I know that.
See? Bottom right, bottom right. Go ahead and add those together. 17 plus 25. 42. 68. Voila. There were only 5 of you who got it right. So guys, gals, your work. I'm going to come around and award you those 5 in a second. Page. 108. Numero 1 and 2. You should be able to do all of this. Your quiz tomorrow is on Pascal's Triangle. Is it the fun? Yeah, it's fun. I advise you to do with a pencil. You're going to do a lot of racing later on. And